My name is Andrii. I came from Sweden. I live in Stockholm. I'm originally Ukrainian, but I live in Sweden for 2 years now. And I work at Spotify as a software engineer. At least I call myself a software engineer. I started my career as being a test engineer in a team of 20 testers, and my work was like kind of, what tester does in most of the companies. They verify A to B, right? So expected results match actual result, and then you rise back if it doesn't work. So it's how I started. Now I work at Spotify to help Spotify teams. Come in, we have space. I help Spotify teams to improve delivery cycle. I help them to be more productive and don't lose the quality, because we believe that with higher productivity you achieve a higher quality of a system and your product. So, and it's what I'm going to talk about. So I've been talking about how I've been using my mindset as a test engineer along the way to transition to be a software engineer, so to a guy who actually writes software. And it's been a kind of tough challenge, so I will try to, combine everything together in 40 minutes. It's the second time I conduct this talk, but I changed it a lot after a time. So what I figured out is that the original name of the talk might be a bit confusing if you're a programmer. How many of you are programmers? Oh, well, okay. So, but please be patient and wait until the end. So if you still be confused with the title and how this title relates to the topic of the talk, just please come in and ask questions and let's talk about those, because there is very big confusion in the industry about what testing actually is. But we'll come to that a bit later. Just to give you some context around what Spotify is a company, how many of you heard about the Spotify? Okay, how many of you are using it? Okay, wow, all right. So you pretty much know about the product. So our goal as a company, as a product, is to help you to find the right music for the right moment. So let's say if you wake up, you want to go away for jogging, like for running, we should match your interest and bring the same music you want to listen during the running. If you go to a gym, for example, our challenge is to give you our challenge to give you a playlist that we will be using to actually, having a workout in the gym. If you try to work, we want to give you like a focused session, like a playlist where you can focus. So it's our challenge to bring, all the content catalog, and we have more than 30 million songs available in the full catalog, and more than 20,000 songs comes every day. So this data is a bit outdated, so it's probably more right now. And also, the user base right now, it says, like on the slides it says 60 million, but now it should be even higher because product is growing exponentially. The product been started in Sweden 2006 by two people, Daniel Ek and Martin Lorentzon. And right now the company distributes along the world, and we have 5 engineering offices, so you understand the scale we operate. We have close to 100 development teams. Every team is like 7 plus minus 2 people, roughly. And those teams are located in Sweden, which is Stockholm, Gothenburg, and three of them in US, which is New York, Boston, and San Francisco. If you heard about Spotify, you probably heard about this article, which Henrik Niebuhr and Anders Ivarsson wrote in back 2012. What they try to do is they try to explain how organizational structure, how Spotify organizes a company, how the organizational structure looks like. When you look at the first time, you might see, it's, kind of matrix organization, right? You know what matrix organization is, right? You have a team and you have projects, so kind of like that, at least from the surface, like when you look at it from the outside. And there are some weird stuff like guild chapters, like what does that mean? But go and read the article, just Google for it, it will give them more explicit. So it's not something that I'm really talking about, just to set the context. But what I found when I joined the company 2 years ago, almost 2 years ago, is that the inside of the company, it does look as the organic structure. So it doesn't look like, as a corporation when you need to go to a manager and talk to a manager of the manager and then wait for the decision to be made so we can actually implement something. So it's not like that. So let's say you're like located somewhere here, you're like an engineer in this squad, and if you want to solve a problem which affect those people, you're like welcome to go and talk to them and just figure out how you want to solve stuff. So it basically gives you more flexibility and freedom as an engineer to solve problems. And it's very essential piece in my work that I've been doing for those 2 years, and there is why I consider this work to be done, this work that has been done kind of successful. We're not in, like, in the way of the. We're still in the journey. So a lot of what I will be talking about is changing over time. So it's not like set of stone or like, or some best practices. There's no such thing as best practice. It's only good practices in specific context. So I will be talking about the good practices in context of Spotify and what worked for us and what didn't work for us. And this probably will be helpful for you as well. So let's start with this example. Let's imagine there is like one of the developer, one of those circles, right? In one of those what we call squads, teams. His name is Peter. And he is like programmer that most of us, and I mean, what usually as a programmer you enjoy? You enjoy learn new things, right? It's what you want to do. If you don't learn, you die. I mean, maybe not you personally, but like my mind dies when I don't learn something new every day. And Peter, like as a programmer, he's very passionate about technology. Passionate, he want to work on the improvements. He want to learn basically something new, and he always likes to build stuff. Just let's go through the Peter's routine. What he does daily, right? So like how maybe like very similar you might find yourself in this kind of outline. Like let's say like this Peter, he wakes up, he starts thinking about some problem. He been working yesterday. It's usually how you solve problem. You don't solve problem just in one shot. At least myself, I can solve it like just right now. I just need some time to think through it. If it's a very complex problem, it takes some time to grasp all the dependencies and the complexity of and get all the specific pieces of the problem to solve it precisely. But later about that. And so Peter he commutes to the office. He like having some sync meeting with his team, like daily. We call it daily stand-up at Spotify. You might call it something similar. And he has some time to actually sit and dedicate to for coding and for the deployment, right? So he coded some work and he deployed it to production. So it went like automatically after some set of processes. And then he had some other meetings, some discussions, got another task to work on, and then every cycle repeats every single day. So it might look very like kind of boring. Yeah, every day does the same stuff, but the trick is that you always learn. So when you learn, it doesn't look so boring. I have a question for you. Let's pick this Peter as an example. So it's a very simplified one. So probably in real life it will be much more complex. You get some different dependencies. Maybe you don't code much. Maybe you spend whole day coding. But if you've been very careful, and craftsmanship is all about spotting details, right? What is the risk in this Peter's daily outline? Where you might see a risk for your product, for your software, for your system. Yeah, he probably did, because he had the headphones on his head, so he probably did. Okay, let's imagine he did. Too many meetings can be one thing. Okay, what else? Missing testing is very near. Commute to work. Okay, how you would change that? Leave at work? Automatic deployment, yeah, might be a problem. Mm-hmm. Yeah, so for me, the main problem is that he deployed the code. Because if you just finish coding and you deploy, and then you cross your fingers and start praying or whatever you can do, like, so nothing won't happen, but nothing bad won't happen. But you never know until you actually, you try. So for me, as a test engineer, having my mindset as a test engineer, the first thing I pay attention to, did you actually do any kind of, verification? Did you actually check before you actually deployed something? Did you actually tested it or not? And like, what first came up in my head when I started thinking about the deployment is like, different types of issues that might happen is like exceptions or timeouts or error from server, error from a client, because I already have this experience as a test engineer. I spent like 6, 7, 8 years testing software, and I know precisely that no one is perfect. I haven't seen any human being, any programmer that never done any bugs at all. Please show me someone who does like perfect programming with no defects. If you're still sure that your software doesn't have defects or bugs or issues, come to me. I will show it to you. We can do it after talk. You can challenge me. I can show you. Yeah. You have to make an assumption that defects are always there. And as a test engineer, you don't try to prove that software doesn't have defects. You try to disprove. Like you try to do it other way around. You try to say that software always have defects, but it's only a matter which of the defects you can find, which of those you can't. Maybe like time constraints, or some different context constraints and some other differences. So let's move forward. Most of the things when you talk about those problems, those issues, or like deployment problems, or like exceptions and like bugs from users, the first thing that came to mind of any engineer I heard, I've been talking to even almost any manager, it was, oh, okay, problems, bugs, yeah, let's hire a tester. Hey, Andrii, can you help us with those testing stuff? Or like, can you help us, improve quality? I say, okay, what does that mean? What does it mean, like, improve quality? Is it only my work improving quality for everyone? Probably not, right? And there are different options, there are different scenarios might happen when you actually introduce a tester to your team. The most obvious one, I mean, it's a very kind of negative case. I start with negatives and then go to more positive. It's like how you do it as a tester always. You start with everything broken, then you try to improve stuff. It's my kind of assumption. World is broken, you try to make it world a better place. It's how you do stuff. So what you start to do? You say testing is the first thing that you say from the so you see from the developers when you introduce a tester, they try to say, okay, we hired Andrii, here's a tester, and testing is not my job. It's Andrii's job. He will take care about it. And this creates a very big problem. I mean, developers, they stop, before they even been trying to care about software, because users complaining, right? You had a bug and say, oh, okay, bug, yeah, I need to fix it. And you have this rushing, time to actually start and fixing problems. When you have a tester, you say, oh, okay, talk to a tester. He will help you to figure out and write this, this Jira bug in Jira, and they will take a look about it later when time comes, which might happen, might not. For testers, even more harder, because as a test engineer, what you're doing most of the time, you will verify all the same things all the time. You should spot, if you spot the details, I didn't say test, I said he verifies, and this is very important. Because what tester does in this case is basically what was the beginning of my career. You just verify A or B for every single build. Does it work or it doesn't work? And you have a list of checklists or test cases or whatever verifications you want to do, and then you just verify the work. Verifies the expected output and current output. And users are still frustrated because, if you introduce a tester to a team and everything that he does, it always does this routine work, it means that this delivery cycle, development cycle, will be slowed down. Because why? Because you introduce one step to your development process. Like most of you who work in the Scrum teams or some of the development teams, how usually that happens, you have a separate QA column or testing column in your Scrum board, and then when something comes to this board, testers say, oh, now I have a job to do, right? 2 days before release, right, or something like that. And the dynamics that I've seen in the teams is when you have a tester who work at the end of the line, then they say, okay, we got the amount of work that we've been doing for 2 weeks. Now it's only 2 days to test it. Does it make any sense? Yeah, and then they say, yeah, here are some bugs. Okay, so next sprint will be bug fixing sprint. Yeah, and then after bug fixing, there is another bug fixing, and then another bug fixing, right? And for user, what does that mean for a user? He's still waiting. And while he's waiting, there is another product out there, Apple Music, Deezer, Erdio been bought by Pandora recently, but anyway. So many competitive, we operate in a very competitive space. So as a product company, we can't afford delays in queues because people just will go to other servers who does it better than us. So we have to find how to do it faster. And another scenario that I've seen, this sometimes is a bit better, but still not perfect scenario, but a bit better. There are some developers who says, oh, testing is boring. It's so boring, I don't even want to do it. I want to automate everything. I will write integration tests, unit tests, component tests, all type of tests, And then, system, Jenkins, TeamCity will run it, everything for me, and we don't need testers at all. Yeah, why do you need? Yeah, I mean, it's a very simple job, just, function, or like Selenium, like open browser, click, click, click there, yeah, fine, it's not a big deal, very easy. And this is, and there is a reason why I put testing in quotes, so it's also a reason for that. But testers still have a job in those teams. So what tester does in that team, they can still contribute by test ideas to the developers. So the way they contribute to the team, they give more testing ideas. What else can be tested in those, unit tests or integration tests or functional test suites? And this is very important because tester has different type of mindset which developer doesn't. Yeah, as a programmer, you can have this mindset if you want to, but it's very hard mentally to switch to it. This goes into discussion between creative and critical thinking. In creative, you create something, and critical, you try to critique your own creation, which is kind of hard. It's possible, but kind of hard. Yeah, and also what tester can do, he can establish communication channels with the users. So one thing is to just collect from Twitter. You can collect this feedback from user voice or different type of systems which help you to collect the data from your users. So I need to speed up a bit. And the questions that came to my mind, observing those two patterns, those main patterns in different teams, I came to 3 questions. How we can spot issues early? It's like we don't need so users don't need to wait to fix those, so we can spot them as early as possible. In case we miss some of the issue during our verification processes, how can we figure out what was the root cause of that mistake? Why did we miss that mistake? Why did that happen? And and the most important thing for the programmers is how to make sure that how to build the process when you fix those problems very, very fast. So users don't need to wait for weeks or months until the bug is fixed. So this fix comes in a matter of hours or in worst case days, not weeks or months. But when I've been thinking about that last year, I seen online, it was a conference in US called DevOps conference, and Elizabeth Hendrickson been presenting her thoughts about feedback, and I said, wow, this feedback is exactly what it needs to move faster. Because if you imagine, if you look on this picture, disregard this for now because credit goes to Elizabeth Hendrickson. If you look at this picture, you go through the bigger feedback loop. Let's say what this might be. It might be like a support ticket from your user, like user complaint on Twitter or something like that. It's the biggest feedback loop you can even imagine, right? And then you say, okay, how can we test, or how we can think of the way to finding the similar problem even earlier? It's like, let's say you try to play music, and music doesn't play. And it might be multiple reasons, right? It might be like a problem on the client side, might be a problem on the backend side, might be a problem, if you go more deep, it might be a specific problem in some playback library very deep in the client, or might be a problem with the distribution somewhere in the data center, might be a problem with the CDN network, might be multiple reasons why music doesn't play. And you try to ask and you're asking those questions and minimizing the feedback loop to the minimum code snippet, which actually fixes the problem, or configuration, or configuration change. And the idea is that for me, it was a kind of main insight, like a breakthrough, is okay. So the way to fix problems faster is to find a way how to prevent them earlier, how to find those defects earlier. And by adding those feedback loops, you can build a set of, like a set of checks. And if software won't go through that set of checks, then you don't go to the next step. And your idea is to try to find as many problems as possible on the lowest possible level. Sometimes it's not, sometimes it doesn't work. Let's say your software, you have monolithic software which doesn't comply to good software design practices. So you even can't isolate it, the logic on the unit level. So the only way to test this feature is to write Selenium functional tests on the staging environment. And this it's a big trigger. So what that means, if you have this problem in your team, that means that your software design sucks. Because if you can't separate the concerns, if you can't separate logic from data and from structures, then how you even make a reason about your system, I don't know. Because if you ask me to test it, I would say, oh shit. I need to spend like the same time you build it, I need to spend the same time to understand how it's actually working in order to test it. And that would be very, very horrible because we don't have this amount of time. Yeah, I can do it. I mean, I have techniques how to break down complexity to like smallest level. But if you want to improve the feedback loop, the feedback cycle, we need to sync together together I mean testers and programmers, we need to work together to find a way how to minimize those feedback loops. So that is why I switched from testing to programming to understand how programmer thinks and how they work. So try to explain to everyone how tester thinks and work, to go the other way around. And basically what I found that you need to start working on sharing. You need to start working on different types of feedback. So what you start from just regular meetings you have as a team, and those goes to any meeting you have as a team. And I urge you to involve testers to those meetings, even if those meetings are very, very technical. By giving testers by giving a feedback can help you to improve your reasoning about the system. So they can help you. They can challenge you. Sometimes they ask stupid questions like, "Why do you use like Elasticsearch?" I say, "Okay, can you suggest anything better?" "No." "Why do you ask?" Because he don't know, basically. Because tester doesn't know what is like Elasticsearch. He never tried this, but it doesn't mean he can't. He can, or she or he. I'm putting like yeah. I mean, it doesn't matter. Tester is the same. It's a test engineer is a software engineer, and but historically, what have happened in the industry is that testers been like hired as people from not having an engineering degree. And this created big problem in the industry. Not the problem that people did not have engineering degree, but the problem was the perception that tester is a job that doesn't require engineering degree. And this is a problem because testing does require engineering degree. This is not engineering degree per se, but at least engineering mindset, engineering skills, and mindset. So same goes to sharing everywhere. So you start sharing the discussions, you discuss ideas, you discuss different solutions. You discuss even the result of your discussions has to be documented, so we can share this discussion to wider audience, not only to your team, but also to other teams, because you might have some dependency between your components, and you want to get all this information as early as possible, right? So you want to outline all your key insights from your meeting and put it in a document, and then everyone can contribute and make comments to you, so also get feedback. And then we just go into the bigger feedback loop right now. And then you do a feedback when you actually start implementing software. You can do pair programming. That maybe not even pair programming. You can pair alone, but then ask what people think about your code, and ask for feedback. You can ask for feedback from a tester as well. Is the perception is this kind of thinking that you need from a tester to be a better programmer? You can have like code review with a programmer, with another programmer, and like having peer reviews before you actually merge. So if you put it like it's kind of workflows that most of our teams using. So let's say when you like prepare the code change and you're ready to merge it to master, we're using GitHub, so you know what the GitHub is, right? And we create this pull request, what GitHub called pull request. I find it a bit confusing because you can actually not pull its push request, but to be like kind of more concrete. But okay, they name it pull request, whatever. And so what you do, like you run all those tests, which tests are also feedback loop, right? So if something breaks early, you will be notified early, and you can fix it without your user noticing this problem. So the earlier you find the problem, the cheaper it is to fix it for in most of the cases. But also you have those 4 blocks are also feedback loop, different types of feedback loop. So it might be just verifications that have been run, code review, it's also like communication with another developer, and actually testing. And testing, I put in testing is a very wide term right now, but testing can be different. You can test on the low level, like on the level of code. You can just open a function and start writing different type of input parameters and different data. Or you can test on the functional level, like open the browser or run your service and just send different type of requests to it. So basically, those tests which you run on different levels, the same testing you can perform on the same levels as well if you want to. we not stop here. It's like you merge, you make a merge, then you have like the master pipeline, so the main pipeline which actually executes all the tests, and then you want to run those tests once again because you don't know what happened after merge. Something might happen. So your idea is to have those tests as fast as possible, so you don't need to wait a lot of time. So you run them in parallel, and you think how you can separate the dependencies, so you can actually write more unit tests rather than functional tests. This test automation pyramid, go into that discussion. So you want to have as more unit in component tests as possible and as less system tests as possible. And your idea is to get the feedback as early as possible. You don't need to wait, and you don't need to wait for until you go to production. But when you go to production, it also doesn't mean you have to stop testing. You can even test in production. And our testers also do tests in production. And if testing in production is the only way, then it's very sad. But sometimes there are like some use cases when you work with the big data sets, for example, you can't control data because of some legacy questions. Testing in production is the only way to do it. So you can accept it for a while, but then you need to acknowledge it as a problem and work to a resolution to fix and test in more smaller isolated buckets. You can do failovers, you can collect A/B test results, you can do alert and monitoring. There's also different types of feedback. And you need to think about those types of feedback in your own system and define what works for you. All those types of feedback, when you think about the engineering, how people build, houses, like apartments. They have those they call scaffolding. So the way how I see those different tests, like unit test, component test, blah, 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 this is your scaffolding around your system. And this scaffolding protects you as an engineer to make changes to your system. So if you make a change, and in case you break something, the scaffolding will let you know, saying, "Oh, okay, you probably changed this window, and looks, a bit shaky because this test that you wrote like a week ago is failing. Can you fix it because you pushed to master? Okay, sure. Before you push to production." So the scaffolding creates kind of safety net around you. And as a test engineer, it's also important to you to have the safety net because it actually gives you more time to work on something interesting. Because you know that all the routine stuff, all the boring things is covered. But in case you break something, you end up in a net. So you won't fall like and die, right? You end up in a net. So in case if something goes badly, you still will be safe because you predicted all the negative outcomes and maybe not all, but sometimes you might fall. But you need to find another safety net under the safety net, maybe sometimes. But in most of the cases, testing becomes more fun because you feel more safe, you feel secure. And if you break something, it doesn't even affect anyone. It just breaks in your own environment or in your own data set or in your own, somewhere. But now we can come closer to the point, what is the difference between tests and testing. If you look, there's very big confusion about it. When you talk about test, there are two meanings. So test can be a noun, and test can be a verb. So what is noun? It's like unit test or integration test, like artifact. What is verb? Like to test or do testing. It's an activity. It's what you do. So when you run the unit test and integration test, it's basically what I put on this picture. You see how you name those. I don't see you do unit testing. You do component testing and say you run tests or you run component tests. But here's where you do testing. So everything before is just execution on some checks that you prepared, some tests that you prepared. And testing happens here, testing happens here. You might do it earlier if you want, but you need to be creative and find a way how you want to do that. But testing, how I reason about testing, I see testing as a process, not as a set of artifacts. And that is the main kind of breakthrough that I achieved in my mind, like a couple of maybe months ago, when I started to understand what testing actually means. And testing as a process which uncovers what your system or product can or cannot do. Because if you execute all those unit tests or those integration tests, for sure you'll be sure the system doesn't break, but it doesn't tell you anything. It just tells you that, okay, system is fine and it operates how you expect it to operate in that given conditions, but you didn't learn anything new. But when you do testing, when you try to open your software and try to basically listen music or add playlists or you do something with it, then you say, oh, okay, if I add this song to a play queue, I even don't know that like the play queue. If I remove the last song from the play queue, it populates another 5 songs before. Just to give an example from the client. But I didn't know about that before I actually tried it. Before I actually like made some action. So this action is testing. But when I wrote a script to automate my action, it's already like an artifact. So it's not testing anymore because I already done testing, and now it's only in a matter of execution and repeating the routine. And it's actually fun because every time you learn something new about your product, it's kind of wow, this kind of insight. And sometimes you learn the bad stuff. Sometimes you learn how you expect system behaving one way and behave another way, and they say, oh, okay, that was interesting. Because if you didn't spot this problem early in the process, then user will see it, and this will be more painful and more costly to the company and to the product and to the reputation. So my main point is that you have to try to do testing once, at least once. And you've seen those patterns that I mentioned before. Like if you find the testing as something boring, there is something wrong there. So there might be something wrong with your software design, might be something wrong with your processes in your team, might be something wrong with how you work as a team together, might be different types of working. So it might be multiple different root causes of this problem. But I would say I compare testing to a programming. Programming is also fun, and testing is fun. So but I still make a distinguish between testing and programming because testing is about the critique, and programming is about the creation. And those two are equally important. So you can't do one without another. If you do only programming, then the only feedback loop you get is just support tickets or user complaints. If you only do testing and focus your full attention on testing only, you won't be able to deliver any new features, which also means you will die as a company because your competitor might do it faster. So testing and programming is always about the balance, and you need to balance and find those two. And this definition, this sentence applies both to testing and to programming. So you need to always find something which is fun for you and maintain this balance between something that you want to create and something you want to critique. So I hope it was helpful. If it's still confusing, please ask questions. We have 10 minutes or so. Or something.
Let's see how much time we have. So we have about 10 minutes left.
Okay. So open for your questions.
Hey.
So do you have recommendation, like you said, you develop for 2 weeks and then it's 2 days for testing and then you find a bug? Do you have a good recommendation that you figure out what to do if it's too late and then you have to release because it merges with all the other changes you want to release? Do you still release a bug or do you stop it and not release everything else?
So the question is, what I mentioned about testing at the end of the cycle, and the tester spends the most time testing 2 days before the release. So this is kind of this type of pattern which we're trying to avoid and try to work through it, because we have this problem mostly in the mobile clients when it's the iOS or Android. So the thing about those clients, as you know, that you have to push your change to the App Store or Google Play Store and then wait for review, which makes it a bit more complex to develop software. So you have a monolithic code base, and you need to sync release between the multiple teams, like 10 or 20 teams, depending on the platform. And the thing is when you run into the problem when it's only 2 days to test, that means you need to start testing as early as possible. And that's why I mentioned this example with testing on the pull request. So when tester perform testing, or even any team member can perform testing even before the code is merged to the master branch. So that means they don't need to wait until all the changes to be merged to test it. And this is actually a problem. What happened in monolithic code bases is like, in order to test the small change, you need to wait for those 5 other changes to be merged as well. And this is a problem. So you need to work with the software design to allow incremental changes. And when you allow those, testing becomes simpler because you can test every single change. You don't need to wait for end of the week to test it. You just can test it just right away. You still might want to test at the end of the week just to make sure the system works together, but this might be covered by those end-to-end tests which runs on a Jenkins or TeamCity anywhere. What's the question?
No.
Maybe just to continue the question. Okay, you are testing during the pull request, you're making builds, testing it, then you merge everything, and at the same time it happened that there were multiple pull requests, each were tested, but when you merge them all, then something broke and you need to release the borrow.
On rare occasions, I mean, the question is like sometimes what might happen is that you have a lot of pull requests, and like 2 days before the release, more pull requests start coming because people try to push their own stuff. And like the thing is how to deal with this kind of pull request mess, I will call it like this. So the thing, what we try to do, at first we develop everything in the using feature flags. So every single feature that we're going to release can be turned off or turned on. So in case someone, like one of the team, wasn't able to deliver their feature on time, they just don't go into this release, they go into the next one. This kind of release trains, and you have like this link, those 2 links, they explain it in more details how this release trains operate. So basically, the analogy you use, you have like a train schedule every 2 weeks, you have a train going, and if you didn't go into first train, you go into next one. It's one thing. Another thing how to deal with those problems is some of the pull requests, you still merge it, but you hide the pull request. If you still have the critical problem, you pull down all other features and focus on fixing this critical problem because this stopping the release. But you always need to be very careful with the priorities, which of the pull requests you need to focus attention right now, which of those you can disregard and just hide it behind the feature flag.
So I believe you have one master code line forever.
For mobile clients, yes, but for backend, no.
Okay, so you basically can fix your bug on production well on the same day. How that concept, what name release actually means now? It's only for new features, basically.
Release means a lot for clients, for mobile clients, because you still have this fixed release date. But for the backend systems and for the web player, for example, it doesn't use this word at all, because every push to master is a release, basically. Not the case for all the teams. Some of the teams want to control the deployment process, but they usually deploy it 2 or 3 times per day. So deployment is a kind of routine; it's not necessity. And I mean, in backend systems and systems when you don't have like fixed release windows, release is not that scary that it was like kind of years ago. So yeah, it's very straightforward.
What could be the main cause for the unit tests and integration tests not to actually catch an error? And what could be the characteristics of such an error that actually goes to a tester and which integration tests do not catch?
This is a very good question. So the question is, in case unit test, what are the errors that unit test and integration test can't find?
Or sometimes or usually can't find.
Yeah. And here's the thing. It's like if your tester spends time verifying expected result and the actual result, you won't even find anything new about your software. Because what tester will be doing during that time, it's the same that unit test is doing, or integration test doing, and he will be missing bugs all the time. And this is what integration test and unit test also do. They miss bugs all the time, because they're not built to find bugs. Unit tests, integration tests are built to verify that your system still works as you expect it to work, but it doesn't look for bugs. It just verifies it works. And what tester does, it looks for new problems. It looks for something that integration tests or unit tests can't find, unless you use machine learning and some other stuff to actually, make machine more smart. But machines are stupid because they just execute something that you already coded for it. yeah, until you have like this how's this called in Terminator, Skynet. Until you have a Skynet, testers will still have a job and developers as well. So, but this goes very wide discussion. Don't want to go there. But like the thing is that you need to be very careful with your unit tests and integration tests, and you need to make an assumption all the time that those tests are not built to find bugs. They just verify that your system works, like a scaffolding around your building. But they're not finding concrete hole in the building. It's what human does when he walks around the building. It's what tester does when he tests software. Another question?
So all this that you told us was about the process which basically happens after the programmer has done his work and committed his changes to the repository. Is there something also that programmers should do while they're developing the code to support testers?
It's a very good question. So the question is what programmers can do to support testers. And this is a very good question, and the answer should come not from a developer, but from a tester, because tester has to request those changes from you as a developer, because he is the person who will be testing it. Assuming that tester is the only person who tests software, but let's say if you're a team of programmers who also want to try out testing and want to learn all the different techniques the tester are using for testing software, then you can improve what's called testability of your system. And testability actually means how easy it is to test your software. If you start implementing your feature and on early discussion phase during the planning meeting, the first questions that you have to ask, how are we going to test it? If you didn't ask this question, good luck. If you do, it will be more interesting because you need to change the whole technical decisions around your software design to make your software testable. And this goes to unit tests and component tests as well. If your software is not testable, it will be even not possible to write very small tests. But if it's testable even for a tester, then it will be much easier. I mean, you're thinking from the testing at the end, and this makes your software design change dramatically. And the answer to your question would be ask during the planning meeting, ask a question, how are we going to test it? And start from there and find the answer to this question. Okay, so we're out of time. If you have more questions, please come in. I will be very glad to answer it.